Welcome to Lesson 2 on Electrolysis, Video 1 for Electrochemistry in Chemistry 2. So today we're going to talk about an electrolytic cell and electrolysis. And electrolysis is basically the opposite of a galvanic cell. So this is the process of forcing a direct current through a cell in order to produce a chemical change. So if you remember before, we used a chemical change in a galvanic cell to produce electricity. This time we're using electricity to produce a chemical change in something. And this is a non-spontaneous reaction. Before, we would have the chemical reaction taking place, and it would spontaneously generate electron flow, and that would be our electricity. This one is what happens if we put something in there. Well, we can use electricity to force a chemical change to happen that normally would not automatically happen. So we're just going to draw a little diagram here. This one looks a little bit different, and there's all different kinds. If we have a beaker, and we have two electrodes in the beaker, and we have those electrodes placed into a solution. And this solution is usually called an electrolytic solution. It usually consists of sulfuric acid dissolved with water and maybe like a copper compound. And we have two electrodes in here. So these electrodes may be inert, or it could be something we want to plate with a chemical. So electroplating is one thing that we can do with an electrolytic cell. So we could put a piece of metal in there and coat it with gold or silver or copper, or any other kind of metal. And one of these electrodes is usually the metal that we want to coat with. And then both of these are hooked up to a power source. So one is hooked up to the positive terminal and one to the negative terminal on a power source through these wires that connect to the electrodes. So what happens is, to have the flow of electrons, we have it coming into one of these electrodes, and then it travels through the solution to the other electrode. It goes back to the power source and completes a circuit. So the reduction reaction happens at the cathode, and the oxidation happens at the anode. So what we are going to do is look at this chart down here and compare a galvanic and an electrolytic cell. So for galvanic, we have chemical energy being transformed into electrical energy. And like we said, in an electrolytic cell, it is the opposite. We're using electrical energy and transforming it into chemical energy in the form of bonds. Here, if we have a positive E value, it is spontaneous. Here, electrical energy is needed for the reaction to occur. So it is typically not spontaneous. So in here, we have two cells with electrodes separated by a barrier. Electrolytic, we usually have the same container with two electrodes in an aqueous or molten solution. So we could have molten salt water or molten salt, which is used for some applications. The electrodes there is a big difference here. The anode in a galvanic cell is the negative electrode and the cathode is the positive. But because we're reversing the flow of electrons, here the anode is positive and the cathode is the negative. So redox is the same for both of these. At the anode, we have oxidation, and at the cathode, we have reduction. So the electron movement is a little bit different. So here we have from anode to cathode in the galvanic cell. So here the oxidation supplies electrons. And over here, we're moving from the cathode to the anode. So the electrons enter the cathode and move to the anode. The power source supplies electrons. So our next video is going to talk a little bit about some applications of electrolytic cells.